Welcome dear students once again. So in the previous classes we have discussed something about algorithms and we have tried to solve few examples like area of the circle. In the previous class we have discussed algorithm to find the area of the circles, and then we also found sum of two numbers also, correct? So let us try to go to the next step. In this I am going to tell you something about flowchart. So algorithm, I hope you have remembered the definition of algorithm. It is a step-by-step procedure to solve the particular problem. So if you know algorithm, then only you can understand the flowchart. Remember students, these are all the foundations for your programming skills. If you know these skills, you can very easily develop the programming skills. Let us go to the definition of flowchart. It is a pictorial representation of an algorithm. Now see this. If you know algorithm, then only you can understand flowchart. Because flowchart is nothing but pictorial representation of an algorithm, or we can also define it as diagrammatic representation of an algorithm. So if you represent algorithm in terms of pictures, if you represent algorithm in terms of pictures or using geometrical figures, that is known as flowchart. You cannot design the flowcharts without the knowing symbols of flowchart. That is why in the first class itself I am going to tell you in details about the geometrical figures that we are going to use in the flowchart. Okay, when you are writing an algorithm, I told you very clearly that the first step is start and the last step will be stop. Why I am repeating these statements again and again? Because I want you to become perfect in these concepts. First step is start, last step is stop, and in the middle we are trying to solve the problem. Okay. Geometrical figure, that is oval, we are going to use for the start and stop. So whenever you are writing start, now don't write step 1. In algorithm we are writing step 1 start, step 2 this, step 3 this, like that. Got it? But here we will not write like step 1. It is already, we have given a particular geometrical for that. Got it? Now look at this. What happened? In the previous class, we have discussed one example for the algorithm. If you are writing start, then use the geometrical figure oval for that. Within the oval, you have to write start. If you are writing stop at the end, then also you have to use the same geometrical figure, that is oval. Then oval is used for start and stop. Go to the next one. If you remembered, in the sum of two numbers, I have written read a comma b, that is also called as input. For input, we are using a geometrical figure called as parallelogram. You might be knowing so many geometrical figures. The parallelogram, we are using it for input as well as output. If you are taking input, write it in the parallelogram. If you are giving the output, that is print sum. Many times you are using print sum, or in the previous example print area A we have printed. You must write it in the parallelogram. The next statement is rectangle, which is very familiar geometrical figure used for the process. Process means I will give you example. S equal to A plus B. What we are performing the task in that particular problem. It may be addition, subtraction, division. Got it? So that we have to use a geometrical figure rectangle. In the rectangle you have to write S is equal to A plus B, or in the area of the circle we have written A is equal to 3.142 star R radius star R, something like that. We have to use a rectangle. Next one is rhombus. Very rarely we are using rhombus. If you go to the next level of problems, then only we are using rhombus, that is conditions. Many times while solving the problem, you may come across checking the condition like A is greater than B, you are using greater than sign there, or lesser than, A is less than B, something like that. That type of conditions we are checking and we are writing in the geometrical figure, that is rhombus. Last but one is hexagon. I am not going to explain this in detail. That is, hexagon is used for looping, because in this class we are not discussing anything about the looping because it is a very big topic. Okay, in programming languages we are using a concept called looping. Got it? So once you are using looping in your flow chart, you have to use a geometrical figure, that is hexagon. Looping means executing the set of statements repeatedly. That we will discuss in the future classes. Last one is arrows. Right arrow, left arrow, down arrow and up arrow. So we are using arrows for the connections. Once you start the flow chart, just write down arrow so that the program will flow, my problem will flow in the downward direction. If there is a twist, you can write arrow, you can use left arrow also. Okay, so arrows will makes a reader to understand how the problem is flowing, that is what is the connections of the flow chart. Got it? So this is something about introduction to the flow chart. Definitely we will try to solve the same problem what we have solved using algorithm. Once I will solve that same problem, you will understand flow chart thoroughly. Okay, so today's session will end here. Thank you very much, students.